Now we're going to go to the project manager. And in here, when I click on that, I have 4 options here. I can review a saved project. In other words, one alignment that I've done before, I can load that up and I can look at that report. I can start a new project for a saved machine. In other words, I've done this before. Now, maybe I was working on it yesterday and I saved it. So I come in today, I can bring this up and I can continue to work on it. We have templates. In other words, I may have done this yesterday and I finished it up, but I want to come back today and look at it again, but I want to do another alignment. I don't care about the data from yesterday, I want to do it. So it'll bring up that template, so all my dimensions are there, but no data. I can create a new machine, which is what we're going to do here. Now when I tell it I want to create a new machine, I have to give that machine a name. Up here you see the machine is flashing. It wants me to put a name in here. So I'm just going to tell that this is demo 1. And in here I could also put the company name, the location, address, all of that stuff. This all gets printed out on the report. This is where we're going to have to enter some dimensions. All right, so we're going to go to dimensions and tolerances. Everything else, you see, we've already done these 2. Everything else is grayed out. We have to do step 1, dimensions and tolerances, before we can do anything else. So we'll click on dimensions and tolerances. Now here, I have a lot of options. This is a standard alignment. This is a standard coupling. That's what I have selected. If I select a spacer shaft, I have to enter different types of dimensions. So we have a lot of options with this software. Okay, I'm going to do a standard coupling. This is our standard alignment. In other words, this is fixed. This is our movable unit. If I had a bolt-bound unit, I could select bolt-bound, and then I have to give dimensions for both units, and then it'll give me the option. I can unlock some feet and lock other feet and find the easiest alignment possible. Okay, we also have a vertical shaft option. These are all options that come with the 680 system. Okay, we're just going to do a standard alignment for this one, and I'm going to have to give this some dimensions. Now another feature of this is the way I'm viewing this, the motor is on my left side. That's the way I'm doing it here. But if I was on the other side, the motor would be on the right. So I could just simply double click this and change the side that the motor's on. So I want to view this the way I'm looking at this. Just makes life a lot easier. Okay, so here, it's giving me these lines. It wants to know the dimension from the center of the coupling back here to the center of the target. And what I mean by the center of the target is these posts, in the center of the posts. That's where we're taking our measurements at. So that's where we want to measure to. So we take the tape measure and we measure from the center of the post to the center of the coupling. In this case, that's 2 inches. So now when I press here, I'm going to get a keyboard that pops up. Doesn't matter if I'm using a laptop or using the tablet. This keyboard is going to pop up and I have to use this keyboard to enter the dimensions. And I set it up for 2 decimal places. So, okay, now it wants to know from the center of the coupling to the first bolt. The first bolt would be, in this case, right here, or up here on this side. So the way I do it is I know it's 2 inches from here to here. I'm going to measure from this post to that bolt and add 2 inches to it. That just makes it a little easier. So we're at 4 3/4, so 6 3/4, 6.75. Then it wants to know the dimension from the front foot to the back foot. So I'm going to measure that. I'll measure it out here. Here we're at 7 inches. And it also needs to know the diameter of the coupling. So we're gonna, This is a 2-inch coupling. Okay, so now we've entered our dimensions. Now we have some tolerances. And we have a chart down here, alignment tolerance by RPM. This is a standard chart that we're not the only ones that use it. It's common, it comes out of Machinery Handbook, I believe. So basically, if the motor is turning, in this case, 900 to 1199 RPMs, these are our tolerances over here. We have acceptable tolerances and we have excellent. So one thing I need to say about that is so many people want to get right to absolute zero. So they'll spend a lot of time, which that's fine, but according to studies, once I get within these tolerances, I'm not gaining anything by trying to go get it closer than those tolerances. I gain absolutely nothing except the satisfaction of being able to get that close to zero. But if you have different tolerances, you don't like these tolerances, you can click this user tolerance and you can put your own tolerances in there. Now these tolerances, they're not going to change the alignment. What they're going to do is they're going to make the arrows go away once you hit that tolerance. The numbers aren't going to change. The numbers aren't going to go to zero. The arrows will go away. The shim values may go away. These are the tolerances I'm going to give it for this motor. We also have here, this is what we call a thermal growth module. If I click on thermal growth module, I can calculate offsets. In other words, I can't go there and say, well, this is what I'm lining. I want to know what kind of offsets I need. I can tell this, I know what the thermal growth is at the front and back foot. And then that will calculate for me the temperature change, I should say. So I could measure this cold using a thermometer, the laser thermometer, and then run it to hot, and then I know what the temperature change is at the front foot and the back foot. And I could tell this by clicking on the temperature one. I could tell it what that change is, the temperature change. In other words, maybe this foot changes 95 degrees in the back, but in the front it changes 125 degrees. Okay? I can tell the material, this might be a forged iron motor. And then I can tell it, I also have to tell it what the distance is from there to the center of the coupling. 7 inches. And then I can hit the calculator button. This is the calculator button. And this is going to tell me here, I don't want any gap, but I want a 7/1000 offset. Okay, I can apply those or I can unapply them. I can do the same thing with the pump. I'm going to turn those off. I'm going to set them all back to 0 so we don't have any thermal growth. And then check there. If I wanted to use dial indicators, I could put a dial indicator here and I could run this from cold to hot and see how much the actual change was. Put those dimensions in there and it would still give me the offsets. Okay, let's move on to taking data. When I get to the data taking screen, I'm sorry, this is still course alignment, but you see here, all I did was align this with the cover on there, with the 2 little holes, and I'm good. Those numbers are green. Now, this is showing me I need to take that target down just a little bit if I want to get better than 30 thousandths. 29 thousandths is good enough, but if I don't like that, I can loosen this and I can lower this down until I'm closer to 0. Once I get that close, the arrow even goes away. Now if this was off sideways, let's loosen it and make it off just a little bit. Now you see, I get a picture on the screen here, tells me to turn that thumb dial down. Turn that down, so if I push this down until my horizontal numbers come in where I'm satisfied, the arrow goes away. That dial is moving that beam sideways, adjusting horizontally. So vertically, I just loosen the screws and move it up and down. Horizontally, I just turn the dial. So it's pretty simple for course alignment. Go to the next screen. Now we have what we call a soft foot routine. There's many types of different soft foot, but we can check for soft foot. The way we're going to do that is we're going to take a reading with all the bolts tight, and then we'll loosen the bolt, and it'll tell us how much change we have. So I got all the bolts tight. I'm going to record that. Now you see it's telling me it wants me to take this or loosen this bolt. So I'm going to loosen that bolt, and I'm going to record that. And then it says, okay, tighten that back up. So I did. And now it wants me to take a reading again with all the feet tight. I record that. And now loosen this bolt. And record that. I'm going to tighten it up. Record again. And now loosen this bolt. Record that. Tighten the bolt. Record. Okay, now I'm going to tighten that bolt. Now this particular unit doesn't have any soft foot. If I had a soft foot, this would tell me, like here is 2/1000ths, that's acceptable, 2/1000ths of soft foot is acceptable. If it was greater than that, it would turn red and it would tell me to either take some shim out there or add some shim to that foot. I would do that and correct it. But now it's good, so we'll just go on to the next step. To go to the next step, we just click on the right arrow. That takes us, if I click on the back arrow, it takes me to the previous step. Or if I click the home button, it takes me to the home page. This says inspect, no shim required. But if I clicked restart, all that data would go away and I could do a moldable check of it. A couple, 3 checks to make